The equinox in September is coming, unless you're watching this video late, in which case it's already come and it's autumn. Unless you're watching this video in the southern hemisphere, in which case it is springtime. To explore the idea of the equinox, I've colored the northern hemisphere a pink color. The northern hemisphere is the half of the Earth centered on the North Pole, the northern half of the Earth, the northern hemisphere. The South Pole is around behind this view of the Earth, but I've colored the part of the Earth centered around the South Pole greenish. That's the southern hemisphere. And where the two hemispheres come together, that boundary is known as the equator. Now, sometimes you hear people refer to the equator as imaginary. Well, the northern hemisphere is real. I live there. I know it's real. I'm presuming the southern hemisphere is real too, although I haven't been there. But if they're both real, then the place where they come together is real. So the equator is that line, and I'd call it real. But now let's imagine a plane, a flat surface that cuts through the Earth at the equator. And the part of the Earth on one side of the equatorial plane is the southern hemisphere, and on the other side is the northern hemisphere. And we can imagine this plane extending out in all directions forever, dividing the sky into a northern half and a southern half. And that division in the sky is called the celestial equator. On one side of the celestial equator is the northern celestial sphere. On the other side is the southern celestial sphere. Now we're using a computer simulation called Stellarium, and we're taking a big chunk of sky and flattening it out on your computer screen. So it looks like our horizon from west to east is curved, and the celestial equator from west to east looks curved. That's different from the way they are in real life when they're not on a screen but surround you on all sides. The day of the equinox is September 22nd this year, and the exact moment of the equinox is 12:20 p.m. Pacific Daylight Time. And in the northern hemisphere, that's called the fall equinox or the autumnal equinox. And I'm noticing that the sun is right on the celestial equator that day. And you might think, well, the sun crosses the sky from east to west. Maybe it's always on the equator. But using this computer simulation, Stellarium, we can investigate that. I've gone back in time a little bit to September the 19th, 3 days before the equinox in September. And look at the sun there. Is it exactly on the celestial equator? Let's go from the 19th to the 20th and see how that moved. And from the 20th to the 21st, and from the 21st to the 22nd, now that's the equinox, the 23rd, the 24th, the 25th, now it's 3 days after the equinox. And I can see that if we have gone from summer to autumn in the northern hemisphere, the sun has crossed from the northern celestial sphere to the southern celestial sphere. And now I've gone back to September 22nd, the day of the autumnal equinox in the northern hemisphere. And it's the equinox because that's the day that the sun crosses from the northern side of the celestial equator to the southern side of the celestial equator. And that's how we mark the change in seasons, the sun crossing the celestial equator. So I've said that on the equinox, the sun crosses the celestial equator, and that's the way it looks from Earth. But looking from space, it's a different story. We could claim here that it's the celestial equator that crosses the sun. Now in this diagram, the sun is in the middle, and it shows the path that the Earth takes around the sun, the Earth's orbit, and it's shown from the side. So this orbit is very close to being circular, but from the side it looks like an oval. Another thing you might notice is that this sun is kind of small compared to the Earth, and if it were to scale, the sun should be much bigger, and the distance between the Earth and the sun should be much bigger, but this is not to scale. We needed to fit it on your computer screen so we could investigate it. Now, you've probably heard that the axis of the Earth is tilted, and it's tilted with respect to the orbit of the Earth. When Earth is in this position, the axis and therefore the equatorial plane extends to the south side of the sun. The sun is on the north side of the equatorial plane, and that's the way the sun is in the spring and summer in the northern hemisphere. As the Earth orbits around the sun and comes to this side, the tilt of the Earth stays the same as it was pretty much, but it's on the other side. So now the equatorial plane goes over on the north side of the sun. The sun is south of the equatorial plane. And sometime between this position and this position, the equatorial plane has swept across the sun. And the time and day that that happened is the equinox. And that's quite a story. You might look at this diagram a little more and think about it. Maybe try to explain it to someone else in the place where you live.